Okay, hello everybody. My name is Tara Skiba, and I am presenting on the remote sensing package that I developed in Python as a part of my geography class. Now, I am a forest biometrician, and so for this project, my thought was to try and help bring remote sensing data to foresters and forest biometricians because there's a lot of potential with remote sensing data, but we have not really kind of utilized it to its fullest extent. And so this project is to kind of try to start that process by making Google Earth Engine data more accessible for foresters and forest biometricians. This is my homepage for this particular package, which is called skiba, and you can find everything that you need in here. We have a publication with a paper that I am currently working on over here, as well as our examples. This is not quite up to date right now. This is not going to match exactly what we are going to look at in VS Code, but it will soon match. And then we have our API references down here. This is hosted on GitHub, so you can also go to the GitHub repository as well to take a look if you want to see anything in more detail or the actual code, and can be downloaded through pip install skiba as it is hosted on PyPI. And so the example that I will start with today is going to be, I believe, the map one. Let me go ahead and switch screens. Um, okay. Sorry, I got a little bit ahead of myself over here. Let's start with this Jupyter notebook called Map. And so first thing we need to do is import our different functions as well as Earth Engine and initialize and authenticate it. If you do not have an Earth Engine account, you will have to go ahead and create an account, as well as follow the step-by-step instructions to get it authenticated and initialized, which I will not cover in this video. So first thing I'm going to do is initialize all of this. And then to access the widget that I created to really streamline the process of querying Google Earth data, we will run this. And now when we look through the documentation and whatnot, everything within this widget, like every process that these widgets um, do whenever we select these different things can be found within GitHub. And so whenever this package was developed, I was developing for a wide range of users, from people who have never even coded a day in their life, which is kind of where this widget comes in. So it's a very point and click friendly um, widget that will later be deployed onto Hugging Face. So that way users don't have to do any of this. They just open it up and they're able to run this as is. But if you do feel more comfortable with doing all of this, of course, you don't have to use these widgets. You can just follow the exact functions as listed in on the GitHub page to access this. So let's walk through this really quickly. We'll start with uploading a file. My file is going to be, I believe, somewhere in my desktop. It's this selected coordinates CSV file. So right now, this only accepts CSV files in a particular layout. It has a plot ID column, which is just a unique identifier that um, the user can have in order to make sure that they know which set of coordinates is located or is associated with which point. It does not need to be called plot ID. This can be called anything. However, the user does have to make sure that their lat and long columns are formatted as quote capitals lat and capitals long in order for this function to run. Later, I can add error handling that will accept alternatives to this, but right now this is currently how it is set up, kind of in order to make sure there is as little user error as possible when running this package and function. So we upload our file, and now we have this drop down of all of the Google Earth data sets, Google Earth Engine data sets available. This is updated daily, so you don't have to ever worry about something new that has been added that won't show up. It should always be there. And for this demonstration, let's use USGS. Let me see. I would like to use their elevation data. Oops, I clicked on something else. Okay, this is the elevation data that I would like to use. So I can just hit enter. And now underneath our widget, it has our selected data set as well as the URL to this data set. So that way, if you want to look at more details of it, you don't have to do the long, strenuous process of searching for and going through all the data sets. It just links you right there. And then through this is helpful because we can really kind of see a little bit more of what we want to extract from this. Um, and it'll also give us our pixel resolution and whatnot. So this should be a helpful feature to help users be able to determine which data set they want to use. And actually, I'm going to switch this up a little bit and use this Terra Climate data set as well, um, as this has more bands than the elevation data, so we can have a better demonstration of what the output will look like. Now, hopping back to here, um, we have these optional start and end dates over here that we do or do not have to necessarily. I will not select anything for these just because I do want the entire data set for this. And then I will hit run query, which will then start the process of accessing Google Earth Engine data, accessing this data set, and extracting the point values for all of our coordinates from this. Now, this does take a little bit of time to run, so I'm just going to let it go. Um, and this will be what you'll see as it's running. First, it generates the URL and tells you the data set it's pulling from. And then it will download the data set to your local downloads folder under the name of the data set selected. So quickly, I will pull that up. Here it is right here. This is Idaho EPSCoR Terra Climate one. And in here, you can see that it produces a CSV file where it has all of the point values for every single band within that data set that the users can use. So this is kind of the extent of what I needed this package to do, because then I can take this CSV file and use it in my predictive modeling, which I primarily do in R. However, this can be used in Python or in Excel or whatever you want to do. But this was kind of the main point of this package, was just to extract these values. However, oh, actually, let me do this really quickly. I also did build this map to go with it. As you know, with remote sensing data and whatnot, making a map can be challenging. Foresters, a lot of them do know how to use ArcGIS, but that comes with the license and it still takes a little bit of time. So I wanted something that really kind of streamlined this process of making a map along with, using these kind of point and click widgets. So this map is incomplete as of this point, but I kind of want to show what I have going on right now. One is just a nice drop down of the different base maps that we can use. These are the base maps from iPyLeaflet that are just kind of built in. And so users can choose which one they want to use based off of what they're trying to show in their map. And then we can also upload the CSV file of coordinate points that we used in our demonstration above. And there they all are, right over here. Next thing, oh, I also have these toggle buttons that can allow you to close out of them so they don't take up too much space when you're trying to take a picture. There should also be a toggle file with this shape file, but the Font Awesome icon that I want to use is it's not loading for some reason, so that's why there's an issue with this. But I did also want to include some kind of like typical Forester shape files that could be helpful for using when using this data set or when using this map. One of them is like the National Forests data set. This does take a little bit of time to run again, so we're just going to give it a second, and then there we go. We have our national forests up here. And so one thing that I should point out is that, let me switch the space map to something a little bit easier to see. Um, this shapefile does not include the national parks. And now my research focuses on the national forest and national parks of the Southeast Appalachian region. And so that's why all of my points are kind of located nicely within these um, polygons. However, the Great Smoky Mountains and also like Shenandoah National Park up here are not part of this national forests file, so that's why those are not included yet. And I am currently working to find that shapefile to include those. And so we'll include additional shapefiles as well. And then we also have the US states, which can be helpful if you are using like the world imagery map where we don't really have those state outlines. And we can kind of have a better idea of where our points are. Also, we do have this marker function as well. As you can see, I've made a few markers on here that we can just turn off. Well, I need to improve that as well to be able to remove those. But yes, we also have a marker function in case anyone needs to make a mark. And now another thing that I'm working on is, if you have a particular shapefile that you would like to add, you can just find the URL to that and manually add it. And so it's like, if you don't want to go and find your own shapefile, you can use one of the built-in ones, or you can customize it as well. And so another thing that I would like to do with this map is to kind of be able to have user customization of the points in case they want to change the size or the colors. I also need to fix, this marker functionality and things like that. But that's kind of where this map is at this point. Now, the data that I work with is the forest inventory and analysis data, which has an issue with confidentiality. Now, the points that I uploaded are the fuzzy plot locations of it, where they have their process of kind of converting their own points into they're buffering their own points so that way you can hide the actual locations of them because some of these are on private lands. So, they don't want people to be able to go and access those places on those private lands. Or, if a private landowner is doing some kind of harvest or timber stand improvement, forest stand plan, or forest stewardship plan, they don't want to know they don't want the landowners to know where the locations of these FIA plots are, so that way they don't manage them differently because they are trying to really capture what is going on without any bias based off of the landowner knowing that, oh, this is an FIA plot right here, let's not touch it. So with this confidentiality agreement, they do not want Google to be able to see the locations of their points. This is even if Google isn't really tracking what they are doing necessarily, they still want to make sure they don't violate this confidentiality agreement that they have. So, while what I just showed was kind of the initial part of this package and still very useful in and of itself, I have created another method that allows FIA to use this without having Google be aware of exactly where the coordinates are. So let me restart this and clear all the outputs. Okay, so this buffer method process works in two steps. One, we have a buffer coordinates function that we will use, and then we also have a buffer methods section. So the buffer coordinates function does not require Earth Engine for this. That is in order to maintain that confidentiality. We're going to make sure that Earth Engine is not running. And I will go ahead and import this. And then this pulls up this widget right here, where again, we can upload a CSV file of the same format as before. I'm going to use the same coordinates that I used in the map Jupyter function or Jupyter notebook demonstration, but let's just pretend that these are the actual confidential coordinates from the FIA. So they can put in their coordinates, and then let's put in a interesting data set. Some of these, are not super helpful to foresters. Not all Google Earth Engine data sets are necessarily helpful to foresters. So there's kind of a lot of searching in these, but we can try, well, we'll just pick a random one. The purpose of this is kind of just to show um, what the resolution is because we'll need to take that into account. So for this one, we can see our pixel size is like 463 meters. Um, and so this may be helpful when we're trying to determine what our buffer radius is, which will kind of take into account plot size as well as pixel resolution in order to still extract the right value for the coordinate point without revealing that coordinate point. And so, for example, FIA plot is around, I think, like 1,800 feet wide. And then this buffer radius was 463 meters, so 1,200 feet. Um, I'm going to say, let's just put in a buffer radius of 3,000 feet. That way we can make sure that we are providing a location that is not within the plot center or the actual plot center. And then we can run this query. Um, this needs to be updated. This is a little confusing as is right now. But really what this process does is it produces a GeoJSON file where the coordinates that are uploaded are fuzzed and somewhere within the buffer radius that we create. And so again, our GeoJSON file is returned underneath the buffer radius that we specified. Let me go grab that really fast from our downloads and bring it over into here so I can run this really fast. Scrolling down, this is where we'll import this buffer method this buffer method part. And then we will have this buffer method VBox in here. And so this part is still kind of in process, but you essentially follow the same thing that we did in the first module where you select your data set. Where it went. Okay, I cannot find, there it is. Okay, so let's see. Here are our selected coordinates right here. And then again, we can select whatever data set that we want, our optional start and end date, and then we can run this query. I'm not going to run this because right now I'm still resolving an issue where I am exceeding the total number of bytes able to be processed at once. And so this is going to throw me an error as of right now, but this is something that I'm currently working on. And so once this works, it should essentially produce the same thing that our Jupyter Maps one produced over here with this kind of data set. But really quickly to kind of fully demonstrate what this buffer coordinates function does up here, we can take a look at this map down here where I am importing the same map. And then let me just change this to the 3,000 foot GeoJSON buffer. And then I'm also going to show our points in here. So that way we can take a look at exactly how these points are buffered within the GeoJSON file. Okay, so we have our points added. Now let's zoom in. And now when we zoom in, we can see where our buffer radiuses are within here and how our points are located somewhere randomly within our circles in order to preserve that confidentiality of it. It doesn't just show up in the middle to where someone can zoom in and be like, oh, okay, I know where the plot center is. It's buffered somewhere within here. And so this package will be presented to the FIA shortly in order to get some of their feedback and see if this is going to be helpful in order to try and help bring that remote sensing data to FIA a little bit easier than it currently is right now for them to use it. So this is my package as it currently stands. I have several more ideas, and I'm sure many more ideas will come as I continue working on this to try and help foresters be able to use remotely sensed data a little bit easier. Soon this will be on Hugging Face. That way users will be able to just go onto this website and immediately do all of this if they want to. However, if you have any issues with confidential data, it may be more beneficial to actually run Python as I am doing now. But that is where I am right now, and thank you for your time.